Dan Perry here with another digital electronics tutorial for Dan on Tech. In this video we will continue looking at Boolean algebra, and we saw some of the basic operations. We saw the ANDing and OR operation. I want to look a little bit more at the NOT operation, and remember what we looked at before was a simple NOT or inverter, and we said that if A is our input and X is our output, that X would be equal to A naught, and that line across the top indicates the NOT. Now, we can use the NOT or inverter with a more complex or multiple operations. We could, for example, have X equals A and B and the whole thing knotted. And we would read that as AB naught. With that, A would be ANDed with B and the results inverted. And we actually, for that, have a special gate, and it looks like an AND gate with a little bubble we use for the inverter at the end, and we call that a NAND, or negative AND gate. Now, if we look at the truth table for the AND gate, let's go back and look at it. Remember, the AND gate, with two inputs, we had, say, A and B with X as our output. Remember, here was AB and X, where in this case X is A and B. But maybe we had instead we had an output, call it Y, where Y is A and B knotted or inverted. Well, what we would have is just the opposite. So anytime A and B was a 0, A and B knotted would be a 1. And when A and B was a 1, A and B knotted would give us a 0. So it essentially, when we knot multiple expressions, we take the output of the non-knotted version, not very easy to say, and we invert it. So here would be A and B all knotted. And notice again the knot line is across both. Okay, we can do that with an OR as well. So if we had a regular OR gate, and with A, B inputs, and X for an output, the OR gate, remember, if both inputs are 0, the output's 0. But if either input is a 1, the output is 1. Well, we could, again, the equation for that would be A or B, where the plus sign we say is OR. We could have A or B, the whole thing knotted, and the output of it would be just the opposite. So if A or B was a 0, A or B knotted would give us a 1. If A or B was a 1, A or B knotted would give us a 0. The symbol for the gate, called a NOR gate, looks like an OR gate with the knot or the circle at the end. So that would be a NOR gate, the ANDing and OR operation. Now, one other gate that we did look at was the exclusive OR. And if you remember, the exclusive OR looked like an OR gate with an extra curve on the tail. And with the OR gate, or XOR gate rather, if the inputs were the same, the output would be 0. If the inputs are different, the output's 1. And we could express that. The Boolean expression for an exclusive OR is A, B, but the symbol looks like an OR with a circle around it, or a plus with a circle around it. And algebraically, that is A naught and B, or A, B naught. And I want you to notice that the naught is not across the whole equation. The naught is just over the A, or it is just over the B. It's not over both. So that would be the Boolean expression for an exclusive OR. And now we're going to take this, what we've built here, and we're going to look at a number of properties and principles with our Boolean algebra to build ways and equations and identities that would allow us to simplify and come up with a essentially a mathematics for dealing with Boolean expressions, Boolean algebra. And once we have those laws, we can go back and we can look at how we can apply the equations to develop a circuit, or if we have the circuit, how we can develop the equations. Well, thank you for watching this Dan on Tech video. Please subscribe to this playlist so you don't miss future videos. Please check out and subscribe to our other playlists on the Dan on Tech channel.